Because we are story, we are using Colab to write our codes. There is no need for installing it because it is already pre-installed in Colab. So, but if you're using, I said if you're using other IDEs such as VS Code, we use the pip install pandas. So if you're using Anaconda, use the pip install pandas. Yeah, and also if using the PyCharm, you can use the pip install pandas. Pip is for package manage. It's a package management in Python. So you can use the pip install pandas. Uh, yeah, for you now to for now like for you now to be able to use it in your programs. So I think I showed you how to import pandas, and I've used the keyword import. This is the keyword that we use to import pandas after we have installed it in our computers. We must import that panda so that we can use it in the file that we are writing our codes. So it is import pandas. Um, in most cases, we use import pandas as PD. In fact, this one we call them aliases. I think you can remember the aliases in SQL. So again,
Excuse,
hello.
yes, from your side, there's a lot of echo.
Okay, sorry for that. What about now?
It's okay.
Is it okay now?
Yeah, it's okay.
Okay, okay, okay. Yeah, as I was saying that the pandas, we import pandas as PD. So this PD is just an alias. Like we were using the aliases in SQL. So again, the aliases for the pandas, we use the PD just to meet pandas. So meaning that in your code you'll be using now the PD instead of writing the whole word pandas. So I think we checked how we can use the pandas to convert now the dictionaries into data frames. And someone can who will remind us what do we say data frames are. I think you can have someone remind us what are data frames. Charlotte, what are data frames? You can just unmute your mic. Sylvia, what are data frames? So kilo.
Okay, data frames are a data structure constructed with rows and columns.
Sorry, I didn't hear you well.
They are data structures constructed by rows and columns.
Yeah, I think it's just a representation of data in a table format. So that is now the rows and columns. So I think that is it with data frames. I think I showed you how to use the pandas now to convert our data from a dictionary. Like this one is a dictionary. I think we used these, right? Uh, I think for the I can just repeat for the people who are not in the class last time. So let me just copy this code and we see how in fact it is just right here. So the first step to convert your data or even to maybe start using pandas, we always start by import pandas as pd. This is always the first step. I think you can just write that. The step one, we import pandas as pd. uh, then the second step is always now to read your data set. uh, Let me just use the loading data set. I think that is the commonly used word. So loading the data set. In this case, we are just using a hard-coded data set. And in fact, this one is what we referred to as a dictionary. This one is a dictionary. This one is a dictionary. So before we convert this one into a data frame, I think you can just try to print it and see its format. So let's just print this. I think you can remember the print function, the cars. If we just try to run this, I think I should comment out this. I think I already have it here. So let me just run this, and we see the output that you're going to get. So you notice that this is our output here. We are getting a dictionary. But now when you are doing analysis, you cannot do analysis with this kind of a data format. It will be difficult for you to do any analysis of this kind of data. So what we normally do here is now converting these kind of data, this dictionary, into something called data frame, or what you are calling the tabular representation of data. Or maybe you can just say that you just want to represent your data in rows and columns. So you always you can do this by defining your variable here, which we are calling it a df to start for data frame, but you can use the name of your choice. So is equals to, using the assignment operator, and then we call our pandas here, the one that we imported, pandas as pd. So it's pd dot, then within the pandas we have something we call the data frame function, and this function is the one that is going to help us to convert these data into a data frame. So it's pd dot data frame, and then we pass our data here. In this case is the cars. So after we do that, we can just try to print out these. Let me just comment out this one now. Let me just run this, and now you can see that we have our data represented into a table format, whereby we have four columns here. And the first column is the one that has indexes, starting from index 0 to index 2. The second column, we have the cars. The third column, we have the passings, and then we have the color. In fact, this one it's kind of you're trying to correct data of cars. You're just trying to record the number of cars. I mean the number of passing a car has done. So that is a BMW. We can see it passing 3 times, Volvo 7 times. We have 2 times, and also indicating the colors. So now with this kind of representation, you're able even to you're able like to read it well. It's represented in a way you can understand rather than having it in this format. Maybe someone it might look uh, maybe we just give just a maybe a non-techie this kind of data. You might wonder what kind of data is this, right? But now after you have transformed it to a data frame, you can see that anybody can understand the kind of data that you have here. I think anybody is able to see that this kind of data is represented in a table format that can easily be understood by even non-techies. But not that is not the reason of us now trying to convert this one into a data frame. The reason why we are converting it to a data frame is now we are able to access so many functions that will enable us to analyze this kind of data. And we are going to see that. So that one was just a case of hard coded values because these are just hard coded values in form of a dictionary. But in most cases, you are going to like to be reading data from external files. And when I say external files, I mean CSV files, the Excel files, what other format. I think in most cases we just read them in form from CSV file and Excel format. Uh, so, is there any question with this? Okay, thumbs up if you are together. Good. I can see that we are together with most of us. So this one was just a case. It's just one use case of this PD. But now we can check how we can read an external file. And in this case, we are going to check how we can read a CSV file that is stored in an external storage. So when you're using Colab, you always like you have to upload your data in you have options of creating a folder to hold your data. And if I just click these, if I just like right click these, you see I have options of creating a new folder. I can create a new folder here, maybe call it something like data, and I notice that it is appearing here, right? So after creating that folder, you can click the buttons, these buttons we have here, these three buttons we have here, right? When you just click these, you should be able to get options. You should be able to get options of uploading your data set, right? And we use these now upload. We have options of opening, you can open your data set, but in this case, we just want to upload. You have other options of creating a new file. You have options of copying a path, but you're going to see how we use the copy path. So in this case, we just want us to upload a data set. So let me just upload my data set here. Let me upload my data set. Where's my data set? Let me see this. I think I should be able to get some data sets from this file here. I'll just choose a random data set. I think you can just choose the exercise data. Just have to press OK. And now when I click this drop down here, we should be able to see the dataset that we have just uploaded, right? Now from this data folder, we have exercise underscore data.csv file. So for us now to do the analysis, we must upload this data in our code. And we said the first step, always the first step is to import pandas as PD. And now the second step is always to load in our data, loading data set. And now in this case, you notice that we want to upload these. So meaning that like unlike in this case that we had a dictionary that we just passed this directory because we had already formed the dictionary. But in this case now you notice that we want to read this file here. So how we load this CSV file? Pandas has a function that is called read underscore CSV function. I think I should read this. Okay, so someone is asking me to share the data set. Yes, I can do that. Let me just try to um, let me see if I can do that very fast. Let me stop sharing for a while. I'll share with you data set just right now. A minute. I think you can just check that in the WhatsApp group. I think you already have the data set. Yeah, you can download the data set from the group. So someone confirm that you have seen the data set. Can someone confirm? Good. Uh, I think now you can upload it in your collab. So let me go back to. Are you able to see my screen as well? Someone confirm. Good. So let's see how we can load this data set. And we are going to use the variable that is called df. And to load this data set, we are going to use the PD, the one that we imported as Pandas upper. Then PD dot, we want to read a CSV file. If you just happen to type PD dot read, you notice that you are getting some options here. If you are reading from a CSV file, you just click the CSV file. If you want to read from an Excel file, you read from you click this one. But in this case, we are reading from a CSV file. So I think I can just click that, and it's always a function. It's a function. So pd.read underscore CSV file, and then after that, you just have like to put the opening and closing marks. Then inside here, we are going to put the path of data set. I think that is something that you should note, the path of our data set. So how do we get now the path of our data set? So this is the data set that we want to load. So when you just put your cursor on your data set here, you should be able to see three dots. So you should click this, and you're going to see options of copy path. This is the option that you should choose, copy path. And then you just place your cursor inside the opening and the closing marks, and then you can just control V to paste the path. You can see that this is the path to our data set. That is the content, and then data, and then our file here, exercise underscore data this .csv. So For you now to check if you have successfully loaded your data set, uh, uh, this is the second check that the check that you should check if the data set is loaded, that is successful. And how do we do this? We just have to print. You can just print df and just click this play button to check if you have your data set. And now you can see that you're able to see some rows of data in our data set. I think you're able to see that in the data set we have how many columns. We have the index column, we have the exercise underscore type, we have the duration, the calories burned, the heart rate, and the dates, right? So I think this is it. How we do it. So this is just a check that you have been able to load your data. Before you do anything else, it's always good to check. You can either do a print. Let me show you another shortcut. You can either do a print or just type df. If you are calling your dataset at df, you can just type df. And you notice when I just type df, I'm also able to see the data set. This is how we confirm that you have loaded your data set successfully. So I'm hoping we are together up to that point. Who has managed to load the data set? Thumbs up. I can see Charlotte has managed. I can see who else? Joseph. Who else? Grace. I, I said that it is always good to also try to do it on your end because some of us after this you are not able to do it on your own. So it's always good to follow as you're doing. So Amos, are you able to load the data set?
I'm still loading it.
Oh, okay, 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 okay. Let's see. Onesimus, are you able to load the data set? Tuze Bida, how far?
I'm still loading it up. It's
Oh, you're
loading.
still loading it.
Uh,
Sylvia?
I'm also trying to load it right now.
Okay, I'm giving you 2 minutes, guys, to do that
Okay.
so that we can move together. It's just easy. You just have to create a folder. Like I can just repeat that process. You just have like to create a folder. You can press your cursor at this point, and then you right click. You create a folder name. You give that folder name. I can call it data underscore one because I already have data. And then you should be able to see that folder here. Then after this, you should position your cursor on this. After that, you should be able to see 3 dots and then use the upload option here. You just have to click that and then it will navigate to where you have, in your case, it will be in downloads, somewhere at the top here. But in this case, I've stored my datasets in a folder that is called datasets, somewhere here. But I don't want to load again because I already have it in place. And also delete these. Okay. Can I see a thumbs up? You have managed. You can see Ericsson now. We have Rodavan, Kilaya, Tuzebida. I can see now most of us are okay with loading the dataset. So I think that is always the now there after importing the second step. The third step now after this, after now you have checked that your data is loaded successfully. So you can always try to do there is some functions here that I'll teach you today that can help you to learn about the dataset that you have loaded. Like there is a function that is called head that will help you to check the first. In fact, by default, it will give you the first top five, the first top five rows of your data set. There is another function that is called describe, and now the describe function will give you again the statistical summary of your data set. So let's start with the head function, and you can just print and then df dot what df dot head. And then you notice that it is a function. It is a function. So it's always a head. It's a head. It's like this. Usually like this. It's a head function. So df dot. It is now from this data set that we have loaded here that we want to see its head, and its head consists of the first five rows of data. So if I just happen to run, I think I can just uncomment this and run this now. So you notice that now I'm able to see the first five. This one will give me the first five rows of data. So if you want to check the last five, there is another function that is called tail. So we can do a print df.tail. So if I could just comment out, I should say that this one is shows the first five rows of data. So the tail now will give me shows the last five rows of data. So let me just comment that and run the tail. And now you notice that you are getting the last five rows of data. That is from 97 to 101. I think our data is 101. I mean 102, because now we always start from index. We always start from index 0, meaning that we have 102 rows of data. So that is another function that you should that will help you to learn more about your data. You can see like in the last five columns, we have at the heart rate, we have at 98, we have at 98 we have a null value here, and also at date we also have a null value here. It's just trying to familiarize with the dataset that you have loaded. So you can use head or a tail. So there is another function that is that will give you the statistical summary of your data. Let's say that it's called describe. Shows the statistical uh, statistical summary of your data set. So we can just uncomment these, and I think the best thing is to add just a cell here. Let me just copy all these. So if I just run this, I should be able to see the statistical summary of my data. Now what am I able to see? I'm able to see the count. That is the count of my the count of all the rows. I should be able to see the mean. I should be able to see the standard deviation of all the numerical columns, the minimum of each column. Again, I should be able to see the lower quartile, the median. This one is the mid. It's the mean or the median. The median, and then I should be able to see the upper quartile, and also I should be able to see the max value in each numerical columns. So again, this one is now helping you to understand. Just we're just trying to understand. Uh, okay, just a minute. A minute, please. Okay, so someone to confirm that I'm audible enough.
And we
Uh,
previously had lost you for the last 3 minutes.
for the last day, yes, 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 I noticed that. I think it's some issues with internet or something. I don't know if it is a fiber cut or something. Apologies for that. But I'm hoping now that you're able to see my screen. I think someone can confirm that. Someone to confirm that you're able to see my screen.
Yes, we can.
Okay, okay, thank you. I think I had an issue with internet, but I'm back now. So I was saying that this function that is called describe, yeah, will help you to will help you to get the statistical summary of your data set. And I think by statistical summary, I say that you are going to be able to get this kind of information. That is the mean, the standard deviation of the numerical columns. You're also going to get the mean value of each numerical column. Then the lower quartile, the upper quartile, the median. Those are some of the things that you are going to get with what with this function. So just allow me to upload my data again here. Just a minute. I think I already have it, so that's okay. So is there any question concerning that? You can ask any question if you have any. Okay, thumbs up if we are together. Yeah. So let's proceed. So I think that was just part of the introduction part of what pandas can do. So let's proceed. I think we have already covered these. So I would like us to check something called locate, and we are saying that pandas use the lock attribute to return one or more specified rows. So meaning that we can get data of a specified row by using these lock attribute. So in case maybe you want to check maybe a certain you want to check data in a certain row, it is possible to check that. I think it's very easy because let's see how you can do it here. We can just open up another another cell here. So let me just try to open a new cell here. So let's see how we can you can get data of getting data of a specified cell on column, or in fact we are dealing with rows, sorry. So getting data of a specified row. Of course we are using the log attribute. The log attribute. So let's see how we can do that. And I'll start by checking if I'm able to access my data. So df.edge. Let me see if I'm able to access my data from here. Like I should try to reload this because I had a network issue. So let me just try to reload this very fast. Let me try and run this. What I want to do with these is print. Maybe print this. Yeah, I should be able to get that. So let's assume that I want to get the data for let's say the row number 4. It's just very easy. I'll just use the print because I want to print, and then I want to get data from that df dot. We use the lock attribute. It's called the lock attribute. And then after that, I'll just use the square bracket and then indicate the index. So index here is the number of row I want to get data from. So if I just want number 4, I'll just indicate that I want to get data for row number 4. If I was to run these, you notice that now I'm getting the data in row number 4. And you can see I have the exercise type, I have the duration, I have the calories burned, the heart rate, and I can see when when this exercise was done. That is on 8th of that is on August 31st, 2022. So this is how we get data from. We get data from a specified row for various reasons. I think that is it. You can just try to get maybe data from a different cell that is index number 94, and also you can see the data that it is at row number 94. So this is how we use it. That is df.log, and then square brackets, and then you indicate the number of index that you want to get data from. So I think that's all about that attribute. It does nothing much than getting the data in a specified row. So let's see what we have next after that. What is this? I think that's all. That's all with this kind of with that attribute. But also, I would like us to check how you can have named indexes. I think you notice something from the data set that we have like in this case here. Let's just try to check this our data here. You notice that by default we have this index that is from 0 to in this case we have from 0 to 101, because this data has 101, that is 101 rows. So you notice that by default we have this kind of indexing. But let's say now we want to have we have something that we call named indexes. So, and with named indexes, I'll just give an example. You can name your indexes how you want them. Maybe let's say we have this kind of data here. They can just remove. Let me just try to write this well. It should be quotes. That is duration and the calories. So this is a dictionary that we have here. A dictionary that has the calories. We have the calories, and also we have the duration. This is the calories burned after exercising for a certain duration of time. And you notice that our data is in what, in a dictionary format. So if you want to have, maybe let's say we want to have we want to have named indexes. It's quite simple. I think I'll just show you. Let me just copy this code and see how it will work. We have day 1, day 2. Let me just try to write this one in a format that the computer will understand. This is code day 3, right? So I can just copy these. Let me just copy these and so let's say we want named indexes. Indexes. Let's see this. We said the first step is always to it's always to import the pandas SPD, and then you can see that our second step here is defining our data. That is data, and our data is just right here is a dictionary. It's a dictionary format. So we have the calories. We have 3 calories. That is 420, 380, and 390, and then we have the duration. What else? I think I can just run these. And I can see I have an error somewhere. Let's see this. Let us just try to fix this very fast. And I think the error is because we didn't have a closing what? That is a closing speech mark here. So let's just try to rerun this. Oops. I'm hoping it runs. And I can see I have another error here. Let's see what could be that. I think you can just let's have these again. Let's have calories. The calories we have a list here of numbers. Let's have 360. We can have 560. Then we can have something like 570. And then we can have the duration. Let's have duration as this. Then a semicolon somewhere. So let's see what we are going to have here. Again, we have an error, invalid and unprintable character. That is in duration. Let me see this. Let me see what could be the problem here. Again, we have that error. Let me just try to start with the duration here. Duration, let's have 42, let's have 38, let's have 39. So let's try to run these and see what happens. Good. So when you just try to print these, we are calling it data. I think you can now we have it as a dictionary. So let's convert these to data frame. So df is equals to that is PD. We want to use PD dot data frame. Maybe I can just delete this. I don't want it at the moment. And I just try to print the DF. So you notice here by default, we have the 0 to 2 index, right? But in some cases, you might want to have named indexes. So how do you implement the named indexes? Because it's not all the time that you want your indexes to be 0 to the number of rows that you want. Maybe you want it to you want to have named indexes. So when you're trying to convert now this one to data frame, you include another attribute that we call index. And now with the index, index will take a list of values. And now this one will take the values that it will take. It will be the name of your indexes. So we can have this one as day one. That is the practice on day one. We can have a practice on day two. We can have a practice on day three. Let's say maybe we are trying to record the data for the practices done at various days. So we can have day one, day two, and day three. So now with these, we should be able to have name indexes. So if we just try to run this, you notice that now we have named indexes. That is day one, the duration of time that this guy exercised, and the calories that was burned, right? We have day two again, the duration that was exercised, and the calories that was burned. Again, we have day three with the duration and the calories that was burned. So this is how we implement named indexes. I don't know if there is any question on named indexes. Thumbs up if we are together. Yeah, good. I think it's just that easy to have named indexes. In fact, we are in the process of feature engineering. We're just trying to see the attributes that you can use during the feature engineering. So a naming of indexes, getting some data from specified rows. These are the kind of attributes that you're going to use. So what else do we check? I think we have already seen how you can load your data load files into a data frame. I think we have already seen that, and we have checked how you can load your CSV. So let's check. I don't think this one is relevant, the max rows, because in most computers is always 60. So this one will always show. We are saying that the number of rows returned is identified in Pandas. You can check. In most cases, in most computers, is always 60. The max rows that your computer can show, and I think I can just demonstrate that. Let me show you here. I think we can just do it from this position. Let me. Why is this? Let me just try to rotate that. yeah, I think I should be able to access it from here. Um, Let me show you something here. Okay, let's start with this. I think I should be able to access my data from this point. Let me check that. bf dot head. Let me just try to print this. Let me just cut that and try to print. It's always good to confirm if you're able to access your data set from, yeah, I think I'm able to access my data frame from this point. But now you notice that I'm getting this data set that you are using here. I wanted to read this data set. So let me just try to read it again. Import df is equals to let me just try to read this data set again. I want to show you something here. So you notice that when I just print the df, what I'm getting here, I'm getting the first five. I'm getting the first five rows of data and the last five rows of data, right? So meaning that we cannot show all the columns. I mean all the rows of data that we have in your data set. So each and every computer has its maximum number of rows that it can display. And that is what I was. That is what we are calling the max rows, the max underscore rows. Sorry. So, like in my computer here, I think I can just check the maximum number of rows it can display, and I can do that. Again, Pandas has attributes that can help us to do that. So we can just say pandas dot options and then dot display dot max underscore rows. So with these two lines of code, we are going to get the number of the max rows that my computer can display at a go. So if I just run this again, I should be able to get 60. Maybe you should try in your machine. And now when maybe I try to say, let's say df dot head, and I indicate that I want to oops, and I indicate that I want to see the first 50. Of course, it will be 59 simply because you are starting from index 0. So if I just try to print that, you should see that I'm able to see the first five. In fact, let me just put 60 and see what happens. Like I should be able to display the first 60. Yes, because now it will go up to 59. I should be able to see all these. This is the maximum number of rows that that my computer can display at a go. But if I happen just maybe to add this one to 60, let's say 61, you notice the now that I'm just able to see the first five rows of data and the last five rows of data, simply because the maximum number of rows that my computer can show at a go is just 60. That is what we know. That is how we usually check the maximum number of rows that your computer can show at a go. Maybe you can just try to copy these this code somewhere, and check how the maximum number of rows that your computer can display. But in most cases, in most computers, it's always 60. So I think that is it. You can check that on at your own time. So what else should you guys know? Let's see this. I think by now you know how to have named columns, how to load data sets, how to check the maximum number of rows that your computer can display at a go. And then the next part of our discussion now should be analyzing data frames. In analyzing data frames, we have already seen the number of I think I showed you the number of functions that you can use to analyze your data frames. Functions such as head, functions such as tail. I think there is a question. Radovan?
So I'm sorry, I kind of lagged behind on where you are talking about the naming of the indexes. So please, if possible, you kind of go back, like just a glimpse of it. I got lagged behind. Thank you.
Sorry, Radovan, I can't hear you well. Maybe you.
Can you hear me well at the moment? Can you
Yes,
hear
yes,
me?
yes, yes.
So when you're talking about the naming indexes, so I kind of lagged behind on that point. So if it would be possible, would you kind of go back to that?
Yes, we can. Yes, we can. Let me just try to go back where we had a named indexes. So Radovan and the others, we were saying that you notice that is in some cases, not in some cases, but by default, let's say we have a data set like this one. This is the kind of data set that we have in dictionary format, right? So if you try to print this data here, let me just comment out this. If you just try to run this, perhaps I should change this one to a data frame. Let me just remove this part. Let me just remove this part. So when I convert this into a data frame, and I even print that, you notice that by default we are getting the indexes as 0 to 0 to 2. This is the number of rows that we have. By default, anytime you load any data set, by default you are going to have the 0 to that is n minus 1 indexes format. But in some cases, maybe you might want to change the names of your indexes. So we were saying that, like in this case, we can maybe try to change the name of these indexes, and maybe you would like to include the days. Instead of having 0 to 2, we can maybe say we can name these ones as days. That is day 1, day 2, and day 3. So pandas come with the index attribute, that is index, and this index normally takes a list of names that you want to name your indexes. So it is index and then is equals, use a square bracket, and then you name your like in this case we just have three rows of data. So we can just pass three names here. In this case, we just have day 1, day 2, and day 3. That is why I had this one previously. So yeah, I have indexes and then day 1, day 2, day 3. So you just have, if I run this now, you notice that I have what we are calling named indexes. That is for day one, we have the duration and the calories. Day two, again, the day three, last three. So is that okay with you, Radovan?
Yeah, that is okay. So I have also another question. So
Yes.
it's like a clarification. So
Yeah.
here, when you're using the locate function,
Yeah.
you are using it together with the row, like let's say row 4, right?
Yes.
So here now we have like the indexes. So will we use the index or will we use the row?
Now to yes, I think that is it's a good question because you have already now named your rows. So during the locating, maybe when you want to locate data in a specified row, it means that you are going to use the name of that name of that name of that name of that what name of that row. You're not going to use the index. Is that right?
Yeah,
Laura?
yeah. Okay, noted,
Yeah,
noted,
yeah,
noted.
yeah.
That's fine.
Yeah, okay. So any other question before we proceed? So yeah, if no question, I think you can just proceed to. I think you can just proceed to what we were saying, analyzing your data frames. And I think I had mentioned some functions. That is the head function, the tail function. Maybe we are going to check another function that is called the info. We have another function that is called the info function. And the info function will give you the information about the data set, just the general information about your data set. Like in this case here, let me show you. Where is this now? I think we have already loaded our data set. Let me see this. Let me just try and see if I can access my data set from this point. That is the let me just use the df.head. I want to print this. Oops, now I'm getting there. Let me just try to see if I can access this. Yeah, I think I can use this. So you are saying that for the describe, we get the statistical summary. So I think you can just proceed from here. Now we have the hash info method showing us or shows the general information about the dataset. So, and this is how we use it. It's just the df info. So if I just run these, you notice I'm getting some information here. So I would like to explain what we are getting here, the information that we are getting here. And we can see that we have three entries. We have three entries in our data set. That is day one. Maybe I can just, let me just try to rerun this so that we can use this data set here. I want to use the data set on the one on in the Excel. Good. So you notice that in this, when I run this function here, I'm able to see the range index, and the range index will indicate the number of rows that we have in our data set. And you can see that in this case we have 102 entries. That is running from 0 to 101. So this is the number of rows that we have. You can call them rows or the entries. We call them entries in when you are doing analysis now, the number of entries. So what else do you get from this function? Of course, you are getting the number of rows that we have, the total number of, columns that we have. In this case, we just have 5 columns. And then we go ahead and even define the names of the columns that we have and their data type. So the first column here is the exercise type. And also you're going to get the information on count, the count of each, that is the count of each column. So like in the exercise type, we have 1 or 2 entries, that is the count. And the data type is of type object. We have the duration, we have again 92, non-null. And you notice that you are getting, these are the non-null. So meaning, I think I should explain this. Like in the exercise type here, we have 102 entries. The non-null. The non-null means that each and every row in this column has data. And what did we say the range is? The range index is 102, meaning that in the exercise type, we don't have any null value in that column. When we come to duration, we have 97, null, meaning that when we take now 102, which is the total columns, the total entries in all the columns, it means that when we take 102 minus 97, we should be able to get that five rows in this column have null values, right? I think you should take note of that. When we come to the calories underscore band, again we have 95, meaning that we have like 7 null values in that column. You can also go to the heart rate. We have 97 non-null values. And then when you come also to date, we have 92. So meaning that we have like how many? We have like 10 rows in this column that have null values. The reason why I'm noting this is because the next step that you are going to check is how now to clean or how to fill those null values. Because when you are doing analysis and you find your data set that has null values, that one can greatly affect your results, right? So meaning that you will always find a way to fill in those null values. And that is why now we're using this the info method just to have an overview of our data set and see if you are going to carry out the data cleaning process. That is cleaning the null values, you know, among other things that we're going to do so that we can clean our data set. So I think that is it. And then we can see that we have the data types. We have 2 data types. That is the float, and we have object type. And that one can be clearly shown on our data type column here. So the next thing that you get to learn about your data set here, it's the memory usage. And this one just say that this one will indicate the storage that this data set has used in your machine. Like in this case, you are getting 4.1 kilobyte. For those of us who don't know the KB, the meaning of KB is the kilobyte. Yeah. So meaning that from this info method, we're able to get a lot of information through just one command about the data set that we are dealing with. So any question on the info method? Thumbs up if you are together. Yeah, I can see most of us are okay with that. So that is another function that will help you to have a general overview of the dataset that you are about to deal with. What else should we? In fact, that one goes under analyzing your data frame. That is viewing the data that you have. So the next step is always the step of data cleaning. And data cleaning means fixing bad data in your data set. And the bad data could be empty cells. Bad data could be data in the wrong format. We can have wrong data, and we can have duplicates. So again, duplicates can also affect your the results. Wrong data can affect your results. Trying to analyze data with the wrong format can affect the results that you are going to get. Also, checking the empty cells. These are the null values in your data set. So let's see how we can clean empty cells in our data sets. And we are saying that empty cells can potentially give you the wrong result when analyzing your data. So, and we are supposed to find a way of removing them, or maybe filling them with data. So let's see how you can remove the rows. And we are saying that one way to deal with empty cells is to remove rows that contain empty cells. That is just one way of dealing with empty cells. And we are going to see how you can remove them. We have a function that is called drop now. This function over here. This one will help you to remove all the null values in your data sets. But it's not all data sets that it's not all data sets that you are going to use the drop now. You notice that maybe let's say you have a small data set, and maybe you notice that by removing what by using the drop now, it means that you're going to drop all the rows with the empty cells. Like in this case, whereby we are getting that. Let's see this. Why is this? Let's use 50. You can just return it to 60. What drop now does, if it finds this row have a null value, it will just drop that. If it defines another row that has a null value, it will just drop that. So let's say maybe you have a small data set, and maybe it happens that most of the rows, either of the column has a null value. You might end up losing a lot of data, right? So it's not it's not all cases that use the drop now, because you notice that when you drop most of your rows of data, it means that that one again will affect your analysis. Because let's say maybe we have, like in this case, we have just we just have one or two entries. And then let's say maybe in the one or two entries, maybe we have like 60 entries, having a null value. So meaning that we are going to reduce our data set by half, almost half, right? And that one can greatly affect also your analysis, because again now it means that you're going to have a small data set to work with. So in cases where you have just a small data set, the drop now is not an option to go by. So let's see other ways you can deal with the empty cells. So the first case is to remove the errors. And the second way to deal with the empty cells is always to replacing the empty values, replacing the empty what? The empty entries with values. And how can we do that? We have a function that is called the fillna. It's called a fillna method. Again, this one is a function that will help now you to replace the empty cells with a value. You might now be asking yourself, okay, uh, who, how do I determine the value that I'm going to use, or maybe to replace the empty cells with? So we have a number of ways you can get a value to replace with. And the first one is you can have a random number. Maybe you just check through the data set that you have, and maybe you can maybe notice the range that you have. Like just checking maybe let's say the duration here. You can easily check that we don't have duration more than 200 minutes. So maybe you can just choose a value that is in between 0 to 150. I can see let me check the largest value here. I think you can just choose a value maybe from 0 to 100, but that one is not always accurate. So you can go further and maybe check or maybe find the mean. The best way is to find the mean. You can find the mean of this column and fill all the null values with the mean value. You can also find the mode. You can find the mode of this column and fill all the null values with the mode. And you can also find the median. You can find the median of this column and fill all the null values with median. So let's see how we can uh, we can achieve that. In fact, it is very easy. For the let's see, for the random values, I just have like to say like the df.fillna with the value that you want to replace with, and then we have another parameter that we are going to pass in our function here that is in place true. So I think I can demonstrate this. Let me just try to demonstrate this very fast. but I don't know how to use that data set. So just a minute. Like I can just copy these very fast because of time. So like in this case, let's see the case where we have null values here. I think you can focus on this column. Let's focus on this column. That is the duration. So let me just copy this very fast. So in this case, just note that we have a null value. We have a null value at row number 51, and we have a row we have a null value at 56. That is in this column here. That is the duration column. So how we can replace that with a random value is you just have to call your df, and then you specify there. You just have like to specify the column. In this case, is the duration. Let's see this. That is the duration column. And then we use the dot fillNar, the fillNar function. So it will take two parameters. That is the value that you want to fill with, and then the in place to true. So let's use a value here. I think you can just use 100, and I want you to check. I want just to maybe you can check the value at 56 in this column, and also the value at 51. So when we run this, let's try to let me just try to run this again. And check if there is any difference at line number 50. Was it 56? Yeah, it was 56 and 51. So you notice that we have filled the line 51, that is in the duration column, with just a random value, that is 100, and also at 56 we have 100. So that is how you and I think there is something that we are being taught here that I think there is something new that just come up. So again, it's always good to check the documentation of this library. But basically that is how we fill. We fill null values with random values, right? So it's just the same as how you can use mean to fill. Let's see this. Let's have mean, and maybe you can have mode. Let's just say that just the median. So how do you calculate the median in Python? So let's say we have our df here, and we want to calculate the mean for the duration. The duration what? I think you can just call this mean mean underscore df is equals to you just have to call your df here. This is just a variable name. So is equals to df and then the column at which you want to check the mean for, and then we have another function that is called the mean function. So with this we are going to get the mean for the mean for our data set here. or maybe the mean over the duration column here. If we just try to run these, we're able to get the mean for that the mean for this column here. So and with this now, we should now be able to fill. I think now we should be able to fill. Let me just copy. Let me just copy these two lines of code here. Let me copy that and comment out this. Let's say fill in null values with the mean, and then maybe I can just let me just paste that line of code here. So it will be very easy now because now we're just going to have the df duration, and then we want to fill now. But now in this case, we don't want to use a random value, because we already this variable here calculates the mean for this duration, and that is why we are replacing the random value with the mean. So if again we just try to run this, you notice that at line 56, oops, let's see this. I think we had already. Let me just try to rerun this so that we can get the data set. The data set with null values. Let me see this very fast. Where is this? Let's run this again. Let's check at line 56. And now you notice that we're able to replace the null value with our mean. So you can check the line 51 and the line 56. Any question? Do you have any question? Thumbs up if you are together. Yes, there is a question from Amos. Amos, kindly ask.
Okay, we can see line 56 has two null, I think null values, right?
That is 56, yeah? Yes.
Yeah, but we have only replaced, I think, one.
That is
Can we
on.
do a replacement of the two at once? Maybe
This is on line
that is line 56.
56.
Yeah.
Yes, yes, yeah. We have. Let's check this together. We have at duration line 56. Yeah, we have filled these, and we have another. We have another null value here at line what? At dates, right? So what is your question?
Yeah, my question is, can we can we replace both of two at once?
At once. You notice that one can
Yeah.
be, yes, that one can be quite difficult because you notice that we have different data types. That is the duration, and now in this case we have dates, right? So meaning that if you want to replace a date, there is a process of now maybe getting the date to replace with here, and for duration, you notice that the mean for duration, we cannot put the mean for duration in the dates. So meaning that you are going to do them in different lines of codes. Is that clear, Amos?
Yeah, it is, but we can try do any replace that if
Sorry,
possible.
Amos?
It's clear, but we can try replacing that for the date.
We can. I think I can't hear you from my end.
I'm saying we are clear, but Can you hear me?
I think you can just try to raise your voice a little bit. Amos? Amos is saying that you try to fix for dates. Yeah, we can fix we can also try to fix for dates. But now with for dates, you really have to convert these to the date format. Let's say maybe you want to let's just try to because of time I think we can just try to replace this with a random value. Let's try that. Fill in null values in dates. This is column. I think it's just we're just using the same format here. Let's see. Oops. Let's indicate that you're using a random date. So in this case, we're just going to pass a random date. Oops. I think you can just copy one of the dates here. And also you should indicate that it is the dates, the date what? The dates column. So let's have to print that is df. I can see we have a null value at that is at column, is it at row 6? You have a null value here. So let's have head. You can just get the first 10. Let's see what we have here. You can comment out this. And now that you notice that row number, was it row number 7? We have fixed the null value. Is that okay, Amos?
Yeah, it's okay. Thanks.
Sorry? Yeah, I think that's okay. That's all about the using the fill now method to replace the empty cells with some values. So I think that's all for today.